Welcome back to linear algebra. Let's jump into Anki to start it out. Here we go. What do we got? What do we got? What must be true of the diagonal entries of a diagonal matrix for D to be invertible? Matrix D. They must all be non-zero. What are the elementary row operations of a matrix? You can swap two rows. You can multiply a row through by a non-zero constant. You can add a constant times one row to another. If an invertible diagonal matrix D has diagonal entries D1, D2, dn, what is the inverse of D? It's basically each of these diagonal entries, the reciprocal of each. If a diagonal matrix D has diagonal entries D1, D2, dn, and if K is a positive integer, what is D power K? It's basically each of the entries, diagonal entries, to the kth power. All right. Okay, then, what did we learn about yesterday? Oh, wow. We finished 1.8 reading. We're actually into practice problems now. And we learned about, operators, two more types of operators. So yesterday we talked about reflection operators. Then we learned about these things called reflection operators, aka orthogonal reflection operators. I gotta learn what orthogonal means at some point, but basically for basically R2, we're looking at taking a point and moving it down to an axis, reflecting it down to the y-axis, down to the x-axis or over to the y-axis. And then we in R3, it's basically moving it to one of the planes. That is a axis plane, essentially, like xy, xz, yz, something like that. Reflecting that vector down onto that one of those planes, and then rotational operator, which is only at this point R2. We didn't talk about R3, but we will later in the book, and that is basically rotating it around about the arc of a circle. And the rotation standard matrix is basically, I think it's cosine, negative sine, sine, cosine. That's counterclockwise, and then if you want it clockwise, you just basically cosine, sine, negative sine, cosine, I believe. You're at the Dude Ranch. Asia. Jump out. Okay, rotation matrix for R2 is good. Rotation operators move points along arc of a circle in R2. Nice. Okay, oh, they weren't reflection. Reflection was, yes, I know what reflecting is. I misspoke. Projection. Okay. AKA orthogonal projection operators. Okay. Project point vector onto an axis or plane through the origin. Okay. On that note, I'm going to grade what I did yesterday, and then I'll be back to recall if I got it right or wrong. All right, so it was actually really close. I just flipped these around, and that makes sense because A is the size of 3, 2, right? So I already had that, but I confused this for being the input. So that means A times X. X is the input, essentially, so the domain is going to be all the potential X. So it's actually going to be a column vector too high, meaning it's R2, and R2 I remember now is that it's not just, it's a set of all, so that is the domain. It's a certain form of denoting the domain, but there you go. And then codomain would be 3, R3. Actually, why is that? Because 3 times 2, or 3 by 2 times 2 by 1 is going to be, that's going to lead to a 3 by 1. That's why. So it's going to lead into a 3 by 1. Okay, makes sense. I'm going to continue now working through more practice problems. I'll be back to recall at the end. All right, so I finished some problems here. I finished finding that inverse with these just variables k that are non-zero. Ultimately finding the inverse being that. We'll check that tomorrow. But inverse, pretty simple to me at this point, I think. You partition it with an identity matrix and then get the left side, the original, into the reduced row echelon form. All right, then with these, so the problems from 1.8 were all about finding domain and codomain in a bunch of different styles. So this one was given an equation. I'm not super strong on the equations. This is probably my most unsure spot, but I think this is x, which means this is what the transformation, it's taking this to this. So now why would that be? I think it's that because it's simplified on this side. It's not like a bunch of other stuff, but I believe that this is potentially that. So that's a 2 by 1. So R2 and R2 for domain codomain, the equation will get stronger. This was a matrix multiplication. Pretty certain I got this one right. This one was based on a transformation equation. I believe I got that right. And this was also a transformation equation, but written a little differently. Transformation formula, different, just written a little differently. And then 11, I'm starting to work on finding the standard matrix. So this is gonna be difficult, but I'll do my best tomorrow to continue working on it and try to figure it out on my own. But I think once I try it, then I see the answer, it will be a lot clearer. So that's it for today. Talk to you tomorrow. See you.